Welcome to Lesson 13, Converting Between Fractions and Decimals Using Equivalent Fractions. Taking a little bit of a turn, moving away from integers and going to focus in a great deal on fractions and decimals. And this equivalent fraction idea, again, this summer's work, hopefully set in stone some of these concepts for you. We've seen them already earlier in the year. This idea of equivalence, very, very important going forward, and something that I wish you to take really close, pay close attention to. Okay, so first we're going to start the lesson off just asking a few questions before we delve into the binder. Now, if you would go ahead and take your spiral notebook that we had from the beginning, you used quite a bit, haven't used it probably in quite some time, but go ahead and put today's date, Lesson 13, Module 2 at the top, and I'd like you to answer these questions in that spiral. We will be discussing them when I see you in class. So, first question is this, and I'd like to have you pause and just write a few answers down to this question. First question is, what are some examples from the real world? Again, remember, the real world is the emphasis in this year, is always applying what we learn in math to the real world. So what are some examples from the real world where decimals are used? So go ahead and write a few of those down and come on back. Okay, I'd be curious to see some of your answers if you've actually taken some time to think about this. You may have more than I do, but there are two that strike me as being the most common uses of decimals in the real world. And first and foremost is money. And we always talk about money in terms of dollars and cents here in the United States. So something like $5.34, always using those decimals, and so we go out to the hundredths place. Okay, out to the hundredths place, which is right here, where that 4 is actually sitting right now. We don't actually. I mean, if you're talking about the stock market, for example, or somewhere where they're talking in more significant digits, you may see something. Stock price maybe 5.345 cents. Okay, so we're talking in terms of, this would be a tenth of a cent right here, but it's the thousandths place. Okay, this might be more common than you think, and that would be in terms of, again, like in the stock market. But for us, our purposes, we talk in terms of we always go to the hundredths place, and that's where it's rounded off to. Another place, my wife is a nurse, so body temperature, when they measure body temperature in internal body temperature in the hospital or at home, your thermometer, normal body temperature is 98.6 degrees Fahrenheit, which converts into actually just plain old 37 degrees Celsius. But those thermometers will register, for example, maybe a 38.5 degrees Celsius, and you might have a bit of a temperature there. And again, you're going up to, into the 101.2. I mean, these are all. I mean, it could be any number of different temperatures. But yes, decimals are used there because one decimal place, especially when you're talking Celsius, can mean a great deal. Okay, and we usually talk in terms just going to the tenths place. Again, of course, you could go to the hundredths. Just thought of another one. I wasn't thinking of this, but in terms of time, when you're going to, we're talking about, for example, in a race, for example, if you're the timekeeping there, whether that be a swimming race or let me just keep this here, body temp. Okay, but also in timekeeping, especially in terms of racing. They go to the, maybe it could be 1 minute 33.45 seconds. Okay, so they get really, really deep into the decimal places there. We're talking about maybe a runner or swimmer winning by thousandths of a second. Okay, so I'm thinking baseball as well. We talk about a person's a batter's. We'll put baseball down here. I think some of you baseball players might have gotten this one, but baseball, we talk about a batter maybe having a 300 batting average. What that actually means is it would be a .300, okay, and that means that is they get a hit 3/10 of the time, or 3 out of every 10 times they're up at bat. Okay, you may see a batting average of maybe 345, which is really good. Now 300 and 345 is really good. Probably more of an average batting average would be like maybe .285, something like that. I got to ask the baseball players out there. But again, that's they get a hit 285 times out of every 1,000 times they're up at bat, because that's the thousands place. But anyway, not to get too deeply into what all these things mean, but look, we've seen money, body temperature, baseball averages, timekeeping. Those are actually 4 that came to my mind. Okay, next question would be, what are some examples from the real world where fractions are used? Okay, so fractions. So go ahead and think about that, write a few down in your book, and come on back. All right, once again, 2 come to mind. For me, one would be carpentry, just building things. Sawing, for example, measuring with a ruler. And again, if you're going to use just standard system, you have 1/2 inch, 1/4 inch. So we have we use very often use 1/2 inches, 1/4 inches, 1/8 inches, 1/16. Okay, so very very common to use fractions when you're measuring pieces of wood to building things. So carpentry, probably number 1 for me, but number 2, very close number 2, would be cooking and baking, because I am we know, and again, but my wife, she's European, so she uses the metric system more fluidly than I do, for example. But I am still always using the recipes where you have 1/2 teaspoon, 1/4 cup, okay, and beyond. So yes, if you look at a measuring cup these days, you're going to see both. You're going to see both in milliliters and also in cups and 1/4 cups, 1/2 cups, 2/3 cups. You'll see that as well on there. So yeah, so I'm thinking the 2 that come to my mind right away: carpentry, cooking, baking. Maybe you thought of a few others. We could share those in class. Okay, so here we are now in your binder, lesson 13. An example 1 here, representations of rational numbers in the real world. We just asked about where you see decimals, where you see fractions. So it asks you here, following the opening exercise and class discussion, describe why we need to know how to represent rational numbers in different ways. Okay, so what we're asking there, for example, do you ever see a recipe that call for 2.7 cups of flour, for example? 2.7 cups of flour. No, we don't. Okay, we don't see something like that, because we have all of our instruments that we've created over the years that are written in quarters and halves and eighths and etc. We don't look at money. We don't say, please, that'll be $3.50, please. Okay, we don't do that. Okay, because we talk in dollars and cents, and it's just the way our system is set up. It doesn't mean that it will stay the same forever and ever, but for now it is. We look in we look at dollars and cents, this way, $3.50, which is $3.50. Okay, 2.7 cups of flour would be 2 7/10 cup of flour. You don't usually work in tenths, and I don't know exactly why our system is the way it is, but it is, and we usually look at we usually start at eighth of a cup, quarter of a cup, and then up, and then we throw thirds in there as well. But the reason we need to learn and to look at these applications is because they exist in the real world, okay? And making this conversion is really, really important, okay? Because you're going to like working in fractions or like working in decimals more so than one or the other will become a favorite of yours. It may be a favorite of yours now. Probably more applicable to most of what we do in life are decimals, okay? They apply not only to our standard system, but they can apply as well to the metric system, which is more worldwide. So knowing both and knowing that this idea of conversion, and in this case, this is going to be more or less simple conversions here in lesson 13 using equivalent fractions. Okay, so let's just go down and get to this example 2 here. So as with every lesson, some of this is going to be pretty basic to some of you, but some of you are going to need more assistance with this and understanding this process. Okay, so use this to your needs. Okay, if you need to look at it over again, find some more assistance elsewhere with these concepts, do that. But if not, if you're getting it, you can probably just buzz on through here. So A right here. So we're going to use place values to write terminating decimals as equivalent fraction. This idea of terminating means these are decimals that have an ending. Okay, such as this one right here, 2.25. Okay, or 2 25/100ths. And if I get into the habit of actually reading decimals using their place value, such as 2 25/100ths, I'm going to help myself out a great deal, because just by saying it, I know exactly where what fraction I am referring to. Okay, so how do we write this number as a fraction? Well, very basically, we have our wholes, which are on the left side of the decimal point. Okay, and that's 2. So we have 2. So in a fraction, this, of course, we know this is going to be a mixed number, because there is a whole portion, and then there's a fractional portion. Okay, so we're 2 and, again, that's the hint with the decimal point, and 25/100ths. Okay, so what you do is you use that decimal point that final number, final digit here, the 5. What place is that in? It's in the hundredths place. Therefore, my fraction is going to be written in hundredths. Okay. Now, this, of course, is a good answer, and it's a correct answer. Okay. It is not simplest form, which is something that we would need to naturally get into the habit of. You can, when it comes to simplest form, you could do it now or you can do it later, as they say. Getting things in the simplest form as early as possible is probably a good idea, because you'll see that your fractions will become unwieldy. They'll become very difficult to manage if you wait too long. But anyway, this is going to be equivalent to 2 1/4. Okay, because 25 is 1/4 of 100, or we could divide both 25 by 25 and get 1, and then 100 by 25 and get 4. Okay, now this hopefully is something that you can see very naturally. Okay, 25 over 100, we talked about money. We talked about 25 over 100, 25/100ths is like 25 cents, which is like a quarter of a dollar, which is a quarter. Okay, so yeah, this would be your best answer right here. Okay. All right, here we go. So we have rewrite the fraction in its simplest form. Oh, that's what I just did. Okay, so that goes over here. I'm sorry. Yeah, that is rewrite it in the simplest form, showing all the steps that you use, and I just showed you that there. And yeah, so if you go ahead and do it, again, we're doing this together. All right. Now the next one, C, what is the value of the number 2.025? Because I am very familiar with decimals, I know that that last 5 is in the thousandths place. So if I read this number here, and that is actually 25. Okay, so I have 25, the number 25 on the right side of the decimal point. Okay, so that's going to be, well, first of all, let's start from the beginning, 2. That's our wholes. And I have 25, I see 25, I read 25 there. 25 thousandths. Okay, so that is 2 and 25 thousandths. This is how I write it as a fraction, okay, my first fraction, or actually mixed number in this sense, a whole portion and a fractional portion. Okay, now I rewrite the fraction in its simplest form, and again, I know that 25 and 1,000 have a common factor, okay, and again, that common factor is 25. So if I divide 25 by 25, of course I get 1. And if I divide 1,000 by 25, I will get 40. Okay, so and I never forget when I'm rewriting this now. I don't forget my whole portion here. So it's still 2, and we have 1/40. Okay, we know that can't get any simpler because our unit, our numerator, is 1. Okay. Okay, so I'll give you a little time here to practice on your own. Again, I know for some of you, you'll just blow through this. Happy for you. Those of you who need extra help, come on back and check in with me with the answers after you go ahead and pause and complete these. And your assignment here is to use place value to convert each terminating decimal to a fraction. Then rewrite each fraction in its simplest form. Okay, so you're first going to do do that conversion, okay, and then go ahead and change it to its simplest form, okay? And again, paying attention to which place value, that final digit of your decimal portion, where that sits, where that resides, that is going to be your denominator in the fraction. Okay, so go ahead and do that and come on back. Okay, so I've taken my first and second step here, and then we will complete this together. Just want to explain this to some of you. Now, the first thing I do is I take a look at my decimal, and we're looking at A right now, and I just want to notice where that last digit is. It is actually resides in the thousandths place. Again, something that we need to know. If you need to be reminded of this, make yourself a place value chart, okay, where you put the name of each different place. Okay, so in this case we have tenths, hundredths, thousandths, so we know we're in the thousandths place. That is going to become our denominator. Okay, and then we just read the number. Just read the number that's on the right side of the decimal point, and that's 218. So that's going to go there. So our first step is here. We've written this terminating decimal as a fraction. Okay, and that's that first part. The second part then asks us to rewrite this in its simplest form. And the thing we need to find is the GCF, and this GCF over here is what we call our greatest common factor. Okay, greatest common factor. Again, I know this is something that you've all seen over and over and over again. And if you did any sort of studying or work this summer, I'm sure you saw it, because this fractions is truly the bugaboo for many of us. Okay, so greatest common factor is the largest number, largest factor that goes into both your numerator and your denominator. Okay. This can be a very tedious task, okay, or it can be a simple task for those of us who are familiar. So, in the case of 218 over 1,000, I would go through a couple of different divisibility rules. like if I add all these digits, 2 plus 1 plus 8, that's 11. Doesn't help me. It's not divisible by 3. Okay, I know it's not divisible by 9 or 6. It is divisible by 2, so I can start there. I don't know, it could be divisible by 4 as well, but I'm going to go with 2 first. So I pick 2, and I see that if I'm picking 2 as my GCF, I know I'm going to have to divide both the numerator and the denominator by that 2, which is I'm doing right now. Okay, and this is going to be, so I have come up with 109/500ths, and now I look at that and I can see the number 109 not divisible by anything else that I know. Again, using my divisibility rules, if I add the digits, 1 plus 0 plus 9 is 10. That does not go along with divisibility rules that I know for example, for 3, for 6, for 9, for 5, okay? So I'm calling this it. This is my simplest form right here. Okay, the next one, again, the steps, and again, if you know all this and you want to zip on by, just zip on by. But again, I have my 0.16, 16 hundredths place. That is reflected here, and the number 16 is reflected here. I know 16 very intimately, okay, and I know all of its factors very easily. I could figure that out, and I know that 4 is the largest factor of 16 that can also be go evenly into 100. So I'll do that, and that becomes my simplified fraction is going to be 4 over 25, or 4/25. Okay, so these fractions that I'm creating here, this 109/500ths is equivalent to this decimal over here. They are the same. They are the same amount. They look a heck of a lot different, but they are the same amount. Same here. The 4/25 is the same as 16 hundredths, or 0.16 over here. They are equivalent, okay? Moving down to C, okay, I know now I have a whole portion, okay, which is that 2, and I write that here. Okay, here's my 2 wholes, and now I deal with the decimal part separately. The 0.72, it's in the hundredths place, that's reflected here. The number I see on the right side of that decimal point is 72. All right, I go ahead, and again, these are some numbers that I do know intimately. 4, I know that 72 is divisible by 4, so I'm going to go ahead and use 4, and if I do the division there, I see, and again, I can never forget my whole portion first, okay, because this is a mixed number now we're creating. 2 and 18/25, because I am dividing 72 by 4 and then 100 by 4, and that's what I get, and I can tell that neither the 18 and the 5 do not have a common factor. Okay, so that is its simplest form. Okay, all right, down to a new decimal place we haven't seen quite yet, and well, yet today. I'm sure you have in the past, and again, not a decimal place, not a place value you're going to deal with much in life. But maybe in terms of, like I said, with timekeeping on races, swimming races, sprinting, etc. But not many times. But you can see here now we have tenths, hundredths, thousandths, and then 10,000ths is our next decimal place. So that is reflected here. What number do I see on that right side of the decimal point? I see a 5. That is reflected here. So 5/10,000ths is, and again, we know that I'm going to go ahead and divide 5 by 5, and I know I know 10,000, of course, is a multiple of 5, okay, because any number with ends in a 0 is going to be a multiple of 5. So 5 divided by 5 is 1. 10,000 divided by 5 is 2,000, okay? So this decimal here, 5/10,000ths, okay, is the same or equivalent to the fraction 1/2000th, okay, 1/2000th, blah, 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 blah. So, one thing to notice, and hopefully you do notice, when we're talking decimals, okay, decimals, and decimal is a very interesting word, and the word decimals comes from the word, the Latin word decimus. Okay, and some of you may know that because I know some of you do study Latin roots. But yeah, so decimus. So decimus means 1/10. Okay, 1/10. Decimus. This idea of dece. Okay, dece. We think of 10 decimus. Okay. For example, if you look, if you are very familiar at all with the metric system, a decimeter, okay, a decimeter is actually 1/10 of a meter, okay, and if we know that 1 meter is 100 centimeters, we know that a decimeter, therefore, is going to be 10 centimeters, okay. And again, we're just going to deal with deci, but of course we can look at centa, which is 100th, okay, which is where our word cent comes from, okay, which is a cent is 100th of a dollar, okay. But anyway, I won't get into that too much. Just keep it here. Now, this idea of 10, if you notice, we go back here, all place values in decimals are all powers of 10, okay? All of these are powers of 10. So when we are talking decimals, we start with tenths. Okay, we start with tenths, we move up to hundredths, and then we go to thousandths, okay? And then we go to 10,000ths, all right? These are all powers of 10, which means this: 10 times 10 equals 100, times 10 equals 1,000, times 10 equals 10,000. Okay? So, powers of 10. Always remember those. It is a very, very powerful system, and the metric system itself is based on powers of 10, and probably a system we should use and should employ more often. We haven't done that because of the cost of changing everything that we have now. Okay, so so let's go ahead and move on and answer a couple of questions. Okay, so here's where things get a little bit confusing. And again, I don't want to scare you, but this is going to take a little bit more concentration. Now, I will tell you there is a shortcut to all of this, and that is to use your calculator. But as we move forward further on into algebra, knowing how to complete these problems without a calculator is very important to the whole meaning of all of this, okay? More of a bigger idea. Resorting to the calculator, again, is acceptable at times, okay? Very often used in assessments these days, but I want you to become familiar, and I will assess you without a calculator on some of these concepts, okay? So just get ready. So firstly, this question here is, what are decimals? I don't know what kind of answer you have for that, but if we're going to look at, let's look at our very, very familiar by now, I hope, number line, okay? And I like this, and if you want to actually write this down, that'd be super. Let's say we have 0 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 1. Okay, so if I look at, now I have taken this this number line, or this portion of the number line, and I have divided it into 10 intervals, 10 segments, 10 units. So each one of these is 1/10. Okay, so each one of these, so this is 1/10 right here. This would be 1/10. My next line would represent 2/10. Okay, and so on and so forth. So if you look at a decimal, okay, taking 1 unit, dividing it into 10 pieces, that means each of those pieces is 1/10 of that unit. Okay, so each one of these little segments here, right here, these are all 1/10 of the entire segment. Okay, very important when we look down to B. Okay, down here it says use the meaning of decimal, okay, to relate decimal place values. All right, so we're looking at decimal place values. We have, this is our tenths place. Here is 100th. This is now 1,000th. Okay, and okay, we'll go one more. And this is 1/10,000th. Okay. So the meaning here, as we step, and we talked about this before on a slide earlier, as I move down the line, what happens is that, or move up the line, okay, move up the line or down the line. When I go from 1/10 here, and we'll color here. When I go from 1/10, all right, and I go down to 1,000th, okay, I have cut, or actually divided this by a power of 10. Okay, 1/10 is greater, is actually 10 times greater than 1,000th. Okay, so what I've done here is I've actually divided by 1/10. Okay, so I have, or actually not divided by 1/10, but divided by 10. Okay, so divided by 10. All right. Okay, so as we move down, we are always dividing by 10. Okay, dividing by 10. All right, so each subsequent place value in terms of decimals is always a power of 10. Okay, therefore 100th is 10 times less than 1/10. Okay, and 1/10 is 10 times greater than 100th. Okay, so always as powers of 10. It's just always remembering the meaning of decimals is using this power of 10. Now, what you're going to find out in this the coming problems we're going to be looking at is when you try to convert. Really easy to convert decimals that are already have a denominator as a multiple of 10. Okay, such as what we said, 2/100ths. Really, I'm sorry, no, decimal. 2/200ths, very easy. Well, of course, is 2/100ths. All right, which is also 1/50th. Okay. So when we move this way and we head that way, a lot easier, okay, a lot easier, and then go to there, okay, very easy. The trick is going from, now how do you go from 1/50th to a decimal? Because decimals do not have 50th places, okay, they only have powers of tens places. They only have tenths, they only have hundredths and thousands and 10,000ths and so on. Okay, so this is the trick, and this is what we're going to talk about now, is how you go from something that might look like this or like this, okay, how do you go from this to a form that looks similar to this? And that's where it gets kind of tricky, and you need to maybe listen a little bit more closely. Okay, so we start off with an easy one, okay, just for example's sake. Write the number 3/100ths as a decimal. Describe our process. Well, 3/100ths, real simple. Our process is, we know we have the hundredths place already, and we know in decimal land there is a hundredths place, so we have 0 holes. Always put your 0 holes in there, okay, and then your point, our decimal point, and we're going to see the number 3, but it's got to be in the hundredths place, okay? So you could do it that way, or if you want to, maybe even help yourself out. And again, I don't know which ones of you need assistance in this, because you're over there and I'm here on the other side of the screen. But anyway, you start out with your 0 holes, put your decimal point, and then you could maybe just trace your little, that's tenths, hundredths, okay? And because this is 3/100ths, I know the 3 needs to be there, And what goes here, of course, is going to be a 0 because I have no tenths in this number. So again, 3, that's what our decimal is going to look like. 300ths looks like as a decimal. Okay, but now you can see it gets a little more complicated. Here's D. Write the number 3/20ths as a decimal and describe your process briefly. Again, you know, I hate to bog you down with this, but it's really important that you put in some sort of words what you're doing and why you're doing it. Okay, we need to get used to this. It's something that's not going away anytime soon. So what I want you to do is I want you to wrestle with that and go ahead and wrestle with D. Wrestle with D, and come on back and let me see what you've done. Okay, so here's D. Again, write the number 3/20ths as a decimal. So here's the thing. First, we need to look at 3/20ths and look at your denominator. And this is not always going to be the case. Okay, you're going to find out that it's not always going to be. This is actually cleaner than some. All right. In this case, the 20, this 20 right here, if you think about it, of course we're not going to convert that to a tenth. We're not going to go backwards that way. But what we're looking for, we are looking to see, here are our secrets here. We're always looking for something that is going to equal tenth, hundredth, thousandths, and so on. Okay. Now, if you look at 20, you know that you can convert 20 into 100 by multiplying by 5. Okay. Now, again, in the land of fractions, we know, hopefully we know, that every time, if you want to make an equivalent fraction, because we want this to be equivalent, okay, it's whatever we create here needs to be the same as this in terms of its value. Okay, so whenever that is the case, we always have to multiply our numerator and denominator by the exact same number, because in essence, well, in reality, what we are multiplying by is simply the number 1, or 1 whole, because 5 over 5, or 5/5 is 1 whole. All right, so if we go ahead and multiply that through, we come up with 15/100ths. So now what we've done is we've taken 3/20ths right here, taken 3/20ths, and we have turned it into 15/100ths by turning this 20ths into a power of 10, which is 100. Okay, 100. And the way we did that is by multiplying by 5. And again, I said, now this is cleaner than others, but right now we're only going to concern ourselves with these 5s and 2s in the denominator. So you see we have a multiple of 2 here with the 20, which is also a multiple of 5. Okay, so we again, this is pretty clean and shouldn't present too many difficulties. It will get more difficult later on. But anyway, so we can see, so then if I'm going to go ahead and extend that through, write it as a decimal, which is what we have been assigned to do, that is going to be 0 because there are no wholes. And again, my decimal point, 0.15, because my last digit of that number here needs to end up in the hundredths place. And there is my my equivalent decimal, equivalent to 3/20ths. These two don't look at all alike. Now you can look at this one, and they look somewhat alike because you see the number 3 sitting by itself here, sitting by itself here. Here I don't see a 15 anywhere in this number. Okay, but there it is. It resides in the in the answer. Okay, so let's go ahead and do this process together right here for the next one. Write the number 10/25ths as a decimal, and again, hopefully when you are, I hope everyone out there is getting into the habit of being able to see, look at, I am trying to convert this denominator here, 10/25ths, into one of these over here. Okay, and again, it's very exciting when you get to the point where you look at numbers and you just know immediately. I know immediately. I know that number 25. I know I can convert it to 100 by multiplying by 4. Okay, and I have to do the same to my numerator. Okay, and that's going to be 40 over 100. And there I go. I have my 40/100ths, okay? I'm not going to simplify here because I don't simplify with my decimals, okay? And again, I could simplify this fraction, but what do I simplify back to? To that, okay? Because I want something to something that has a power of 10 as a denominator. And I'm going to go ahead and go through 0 and 40/100ths, okay? Now 0 and 40/100ths is, when you're talking in terms of decimals, if you have a 0 as your trailing digit in your decimal, your trailing decimal, it is not needed, okay? You need these, like for example up here with the three hundredths up top here. You need this 0. This is very necessary, okay, because it is holding the place of a tenth, and it's telling you there are no tenths, okay? All right, so your last significant digit is going to be filled in here. So we don't need this. So that, while this is correct, 0.40, 40/100ths, 0.4 or 4/10ths will do. Okay, and we could have actually simplified this 40/100ths here. We could have gone down to 4/10ths as well, because that is also a power of 10. Okay. Okay, so this last one here up at the top, before we get into some these next in exercise 2 that are going to present a bit of a challenge. 8/40ths as a decimal. Okay, again, if I am looking at that 40, what I know about the number 4, for example, is that 4 times 25 is 100. So I'm working from that perspective. I know that 4 times 25 is 100. Therefore, I know that 40 times 25, because I'm just adding a 0, is going to equal 1,000. Okay, so I'm going to go to that thousandths place right here. So I'm going to go ahead and multiply 40 times 25. And again, what I need to do the same with the 8. And so we know that this is 1,000 and this is 200. Okay, do my multiplication there. And I know I can go ahead and trim 2 of these zeros off. Okay, each one. So I have 2/10ths, which is 0.2. Okay. All right, and hopefully that wasn't too fast, but I want to move on. We're at 42 minutes right now, and I don't want to make this too long because the next part's going to require a little more time. Okay, so here comes a bit of a trickier one. I'm going to show you something of a shortcut, but it may not look so short to you. But if you know your use, if you have any kind of familiarity with the use of powers in numbers, this will excuse me, this will benefit you. So if I look at 3/16, now when you're looking at these numbers have been chosen, actually these denominators here have been chosen very specially, because before we were looking at powers of 5, if you recall, everything could be divided by 5 or multiplied by 5 to get a power of 10. Here we're looking at a power of, we say a power of 2, and of course it's a power of 4 as well, 4 squared. But we want to look in terms of powers of 2 and 5. And 5. And I know this may be complicated for some of you. If some of you know this already, you might want to zip on through. Those of you who don't, this could be very helpful in your future. So if you do, and again, this is to convert to find a power of 10. And you can see that we could use a power of 2 and a power of 5 to get any power of 10, because as you know, 2 times 5 equals 10, and that's the magic right there. Okay, so this is 2, and pretty much we're going to put a power here. That's 2 to the first times 5 to the first power, okay, equals 10. All right, so keep that in mind. So if I look at this 3/16, I have 3, it's a power of nothing, it just stays by itself. 16 in terms of 2 is actually 2 to the 4th, well, I should probably put 16th here first. Let me do that. So 16th here, so that equals 3 over 2 to the 4th power, because 2 times 2 equals 4, times 2 equals 8, times 2 equals 16. Okay, so 1, 2, 3, 4. So 2 to the 4th power is the same. Now, the rule is, for any power of 2, if you multiply it by the same power of 5, you will get a power of 10. Okay, so for example, then we're going to go ahead and do this. So if we're going to multiply, that means we would multiply this power of 2 times 5 to the 4th power. Okay, so it's the same power as this one. So you can notice that here. So I'm looking at 16 as being 2 to the 4th power. Therefore, I can multiply this 2 to the 4th power by this 5 to the 4th power, because I always have this similar power here. Because over here, remember we had 2 to the 1st power times 5 to the 1st power is 10. This is always going to work. It's going to continue to work forever and ever. Okay? So, again, what we do to the top, we need to do to the bottom, we need to do to the top. So we have to multiply this 3 times 5 to the 4th power. Okay, and so what we're going to do here then, now we have to figure out what 5 to the 4th power is. If you have a calculator, you could do that, or you could just do it like this. 5 times 5 equals 25, times 5 equals 125, times 5 equals 625. Okay, so 5 to the 4th power is the same as 625. So now we have to do lots of math involved in this. Fun for me, fun for some of you, maybe not fun for all, but really good to get used to this use of powers. Again, as we move further on in algebra, exponents are going to become more and more prominent and give lots of kids lots of headaches. Okay, this is why we become familiar with it now here in 7th grade, make it a lot easier eventually. Okay. So again, we're going to do our multiplication. Go ahead and multiply through here. So 3 times 5 to the 4th, which is actually 625. Okay, and we could just do our multiplication here. We'll just erase all this later. And that is, okay, and again, hopefully this is not a bear for you, but that's 1,875. Okay, these numbers are getting big now. And now we're going to go ahead and multiply across on the bottom. We know 2 to the 4th power is 16, and then times 625, and I'll just cut to the chase. That is actually 10,000, okay? And that's what this number looks like. So as our decimal here, or as our fraction, our final fraction right here, which is written in a power of 10, we have 1,875 over 10,000. Okay, over 10,000. We can't do any simplifying here because 1,875 does not end in a 0, so we can't actually simplify there. So the way we write that then is 0.1875, and you can see that our 5 here ends up in the 10,000ths place. Okay, so these two right here, or all of these, are equivalent. This, and this are all equivalent, all equal the same amount, okay? But very, very interesting, a process that I hope some of you will continue to employ into the future. Actually, how about we employ it in, well, maybe not B, but how about C? Let's go ahead and clean this whole slide up. You guys could always go back to it. I'm going to lose everything right. No. There we go. Okay. So we know this equals 0.1875. All right. Just remind us all. Now 7 over 5, or 7/5, a little bit different, not as difficult. Of course, this is going to harken back to what we did prior, the exercise before this. We can change that 5 down there into a power of 10 by multiplying by 2. And then, of course, we're going to do the same to the top. So that's going to be 14 over 10, all right, which equals 1 4/10, because as a decimal, we don't write, we don't use improper fractions. We don't use, but we can create a fraction. We can create a decimal not as easily from an improper fraction, but more easily from a mixed number. So that, of course, oh geez, I'm sorry, I made a boo-boo here. That should be 4/10, okay, which equals 1 4/10, which is 1.4, 1 4/10, okay. So simple, real easy. Again, because we have that 5 down there, which easily transfers or converts into a power of 10. Yeah, super. We wish all could be like that. Now, 11/32, a little bit different. So what I'd like you to do, then if you need to back up a little bit and go to, because I've lost that other slide by erasing it all right now, but if you go back to that in the presentation, that could possibly help you figure this one out, because this problem is going to be a lot like this one, because if you remember, we looked at 16 as a power of 2, which 32 is as well, okay, and the power of 2 was 2 to the 4th power. Remember, we multiplied both of those by 5 to the 4th power because it was the same power, okay, and then we multiplied this by 5 to the 4th power, and we did all the rest that you might remember. Okay, so go ahead and do that. Try it. Give it a try. Come on back with an answer, and we'll go through it together. Okay, so I just got started here. Hopefully you came up with the right answer and figured this one out. You were very successful. Now, you can just harken back to up here. If you know 16, it might be really handy actually to get all your powers of 2. Make a chart. Put it in your book. Put it in your spiral notebook. Be very, very helpful. Something good to know for the future. All your powers of 2, powers of 5, powers of any number, but 2 and 5 often come in handy. So if we know that 16 was 2 to the 4th power, we know that we just multiply by 2, 16 by 2, and we get 32. So therefore, 32 is actually the same as 2 to the 5th power. Okay, and going back to our rule that all we have to do is multiply 2 to the 5th power by 5 to the same power, which is 5 to the 5th power. Okay, and we'll have to actually do the same to the top. All right. So if we go ahead and do 5 to the 5th power, we know that 5 to the 4th power, if we remember, was 625. And then if you multiplied that, you would get 3,225. Okay, so 3,225. 225, and then times 32. Okay, and that's what I'm multiplying across here. So this is 32. This is 3,225. Okay, I took a break there. I went to my calculator. Sorry, being a little hasty here, trying to get through. But anyway, yeah, but 625 times 5 is actually 3,125. Okay, so that's 5 to the 5th power. And if I go ahead and multiply that by 32, I get 100,000. And if I multiplied that times 11, I think I had 10 here written before, I get 34,375. So what do I need? I need a 0 because I have no holes. And then I have 3, 4, 3, 7, 5. Okay, so that ends up in the 10,000ths place. So, yeah, 34,375, I'm sorry, I said 100,000ths place. 34,375 100,000ths is the same as this in the decimal form. And actually, believe it or not, 11/32 equals that. Pretty strange. And, of course, knowing all this powers of business, very, very helpful in the future. Okay? But, as you probably know, you can very simply do this on your calculator, because 11 divided by 32, if you punch that into your calculator, is going to give you this number right here. Okay, but I'd like for us to please stay true to working with the powers. Okay, and I almost missed D here, and D was a simple one to end up on a simple note. Easily to go from 50 to a power of 10 by multiplying by 2, and did that to both the numerator and denominator, got 71 hundredths, which boils down to, or simplifies to 7/10, still a power of 10, and which gives me 0.7, which is 7/10 in decimal form. Okay, so here is our lesson summary. Any terminating decimal? Again, that's a decimal like 0.125, okay? The only thing that's not a terminating decimal is a decimal like pi that just goes on forever, has no terminating number, does not repeat either, okay? So any terminating decimal can be converted into a fraction using place value, okay? 0.35 is 35 hundredths, or written like that, 35 over 100, okay? Pretty simple, probably more simple than the other way around, okay? So when a fraction whose denominator includes only factors of 2 and 5 can be converted to a decimal by writing the denominator as a power of 10, okay? So this idea of powers of 10 and 2 and 5, okay? So if you have a denominator such as 16, for example, we learned that well, let's do 3. Remember 3/16. This is a power of 2. Therefore, it can be converted into a power of 10 by using the similar power of 5. Okay, but if you have a number, such as not 18. Yes, 18. So if you have 18, 18 is not a power of 2. It's not a power of 5. Okay, and we're not talking about divisibility now. We're talking about powers of. Okay. It's not a power of 2, not a power of 5. You're not going to be able to go through this process. Okay, that would be a different process. That's more or less a calculator process there. But yeah. So anyway, that's where we stand. Hopefully, this is will all become clearer and clearer to those of you who are a little fuzzy right now. So go ahead and finish your problem set. What I'd like you to do this time is I'd like you to go ahead and complete your exit ticket, and I'd like you to submit it at Google Classroom. Okay, so lesson 13 exit ticket, I'd like you to submit that at Google Classroom by taking either a snapshot, scanning it, and submitting it. Okay? Alrighty, well, good luck.